Welcome back to our video series Demystifying 5G, discussing 5G and our network coverage measurements. The last time we looked already at the measurement results, so this time I would like to go over the configuration with you, how we use the software to configure our scanner to take these measurements. So let's get back and stop the measurement here to look at the configuration. So of course the very first thing that we will do is we're looking into the hardware setup. So basically what I did is I loaded the 5GNR driver with our TSME. If I'm loading that driver, you can see here I can set my frequencies. What I did in this particular case, especially for non-standalone mode, I'm driving it in an expert mode. So where we find that, so we basically go back and go here into the advanced tab, and I would have to put that check mark in here. That check mark would give me all the freedom and flexibility that I need to configure the measurement setup. Otherwise, it's just already prepared for standalone mode, and it would sweep through the global synchronization channel number raster, like I explained in our technology overview. So let's go back. So you see here basically the scanner would be able to do an auto detection, but like I said, I know my network configuration and I know that's exactly above a 3 gigahertz signal. You see here on my signal generator, I didn't do a power ratio between the primary and secondary synchronization signals, so that's why I unchecked the 3 dB setting here. The network or the standard allows for this, so the scanner would be able to detect both. Of course, if you tell him there's no ratio, then he would ignore that setting. So we can do that here. Like I said, I know my configuration that I put up. And that's basically what we can do here on this side in putting the expert mode in. So if I hit OK, the only thing I need to do is setting the frequency. In my example, like I said earlier on, it is at 3.5 gigahertz. You see here the so-called SSB pattern. That's basically the mapping principles that are defined by the standard. They depending on the subcarrier spacings that we are using. I'm transmitting here at 3.5 gigahertz using 30 kilohertz subcarrier spacing. In that sense, we would have a case B or case C option, how these SSB blocks are mapped from a timing pattern point of view. I use the configuration case B in that sense. And then you have here the periodicity for these blocks, like how often they are transmitted. The standard allows for the options shown here, 5, 10, 20, 40, 80, and 160 milliseconds. In my example, I'm using 10 milliseconds. The default value that the mobile will assume while I'm just switching it on would be 20. So that's something that just being set in the standard. But as I said, my example is here 10 milliseconds. So this is the configuration where I'm basically telling the scanner which frequencies to scan for. If I'm doing that, of course, it will load that configuration into the scanner hardware, and we could start our measurement. I would like to show you one more thing in this case, here the technology description. So you basically can look into these different settings that we have. As an example, the transmit power that the network may use for these SSB blocks could be put in here so that we do a path loss calculation, which is kind of an important, not just SIP 6 gigahertz in my example here, but definitely at millimeter wave frequencies. So you can assess if how the network is deployed, a link budget could be fulfilled, important. And then one more thing that I would like to highlight here is then of course the thresholds that we can set. Similar, this would be coming over the established LTE connection towards the mobile phone, so that the mobile knows what are the thresholds at certain RSRP, RSRQ, or SINR values that you see here put in as default. The mobile would know that this is a SSB block that it should include in the measurement report or not. So the scanner would, of course, measure always these things, but as it is very sensitive, but these values are taken into account if we assess NR cell quality, like I showed you earlier. So what does that mean? Basically, if the SSB is beneath that threshold, we wouldn't take it into account to do the cell quality estimation. If it is above, then it's taken into account. So these are the kind of settings that you can do. So you can really use the scanner and correlate the measurement data with what the device would measure. So when we have configured all of that, of course, we would be ready to go. So let's start that here real quick one more time. Because to do this walk test, drive test, you're always interested in the performance and the history. We talked so far only about 2 views, so there's more that we can add in the software. So let's take a look here. You see here scanner views, 5G and R, and like I said, we have only 2 activated at the moment. So let's add quickly the history view and also the performance view. So I'm doing that here right now. Let's reorganize my windows and let's talk about these new additions. So first of all, the history view, I think a very interesting one here. If you have multiple cells that you want to detect and measure, like a small cell deployment scenario as an example, then you would see that here, which one of those cells is the best one. But importantly, as you can see, we have here the PCI that is detected. Right now I'm generating only 1 cell and 1 SSB pattern, PCI 256 as we used throughout our example. And then you see in that case what is the strongest SSB index or block that we detected. Of course, I'm not moving here and we're transmitting everything with an equal power. That's why you see it rotating. But over your drive test, we would always see like, okay, at this moment in time, this particular SSB index was the strongest one and so forth. And that could be nicely correlated with what the mobile is seeing. And so you can use that for optimization of the network. So the next item we will look at is the SSB performance view. So let me enlarge that here in the software that we can take a closer look. So what you see here is basically an assessment of the performance for RSRP, RSRQ, SINR values based on the detected SSB indices. And you see here just over time how we measure that, and you can now do your walk test, and of course you may find different coverage and results for the different SSBs. So this is basically a great tool to do and take these looks. And as you can see, there's quite some capabilities within this particular software to measure initial 5G and R network coverage and performance and use that for optimization. So what I did here is a very simple demonstration. I'm using 1 carrier at this moment. And I put 1 SSB in there. The question is does the standard allow for more SSBs and so forth? But this is something that we will discuss in another video in our video series, Demystifying 5G.